Hello everyone, welcome to another video by BiteSizedMed, where we will be discussing about the pathophysiology of internuclear ophthalmoplegia. Now, internuclear ophthalmoplegia is quite difficult to understand to begin with. However, once you get the hang of it, it's not quite complicated as it may seem. So let's see what the problem is. But before we do that, imagine this is your right eye and this is your left eye. So this is your right eye and this is your left eye. Now imagine you want to look at the left side because there's an object here on the left side. So for you to look on the left side, the left lateral rectus muscle, the lateral rectus muscle on the left side needs to contract so that you can look at the left side. But your right medial rectus muscle should contract so that you can look on the left side, right? So for you to look on the left side, lateral rectus muscle on the left side needs to contract, but on the contralateral side, opposite muscle, that is the medial rectus, needs to contract so that you can look on the left side. Now this is mediated by communication in the brain between the left-sided or the lateral rectus muscle of one eye communicating with the medial rectus muscle of the contralateral eye. This is how you are able to look at one side using your eyes, using both of your eyes. And of course, for you to be able to focus on an object, both of the eyes need to focus on that. Both of the eyes need to be seeing that object, otherwise your vision will be diplopic, right? Now this seemingly simple thing that happens in our eye is actually mediated by a complex pathway. Now let us look at that pathway. So we know that the nerve supply of lateral rectus muscle is the sixth cranial nerve. Just a quick reminder, we know the mnemonic LR6SO4. So the lateral rectus muscle is supplied by sixth cranial nerve, superior oblique is supplied by fourth cranial nerve, and remaining extraocular muscles are supplied by the third cranial nerve. So based on this mnemonic, we know that the medial rectus muscle is actually supplied by the third cranial nerve. So in our condition, the sixth cranial nerve has to communicate with the third cranial nerve. How does it do this? So the nuclei of sixth cranial nerve is in the pons. This is where the sixth cranial nerve nuclei is present, and in the midbrain is where the third cranial nerve nuclei is present. All right. So why am I why have I written sixth cranial nerve on the left side and third cranial nerve on the other side? Is because the sixth cranial nerve of the left side needs to communicate with the third cranial nerve of the other side, so that lateral rectus muscle can contract, and also at the same time medial rectus muscle can contract, right? Now this connection is actually made by a fasciculus which is known as the medial longitudinal fasciculus, MLF. Now if there's any problem with this median longitudinal fasciculus, let's say on the right side, if there's any problem with the median longitudinal fasciculus on the right side, what can cause these problems are stroke and multiple sclerosis. There are other conditions also, but more prominently multiple sclerosis and stroke, even more prominently with multiple sclerosis. If there's any problem with the median longitudinal fasciculus of the right side, imagine you want to look at an object which is on your left side. Your left lateral rectus muscle will contract and your eyes will look to the left side. So this muscle will contract and your eyes will look to the left side. But unfortunately, because there's a problem here with communication, the eye on the right side will fail to adduct. Okay, it will fail to look on the left side, it will fail to contract. So this right eye will look straight ahead, that is, it will fail to adduct, and this will abduct, right? This will look on the left side. Now what does this tell you? This tells you that to find out where, at which side is the problem with medial longitudinal fasciculus, you have to look at the eye that fails to contract, or the eye that fails to move, the eye that fails to adduct. So in this example, if there is a problem in the right side, the right eye will not adduct, it will look straight ahead, right? And this eye will go into horizontal nystagmus on left side. Now in the comments below, please let me know that if there is a problem with medial longitudinal fasciculus on the left side, what would be the clinical findings of this patient? I hope you understood this concept and the two components of